Hi, I'm Tanvir Ahmad. I'm from Team 9. My teammate is Chaitanya. We are working on object detection on non-iconic images using CNN. Uh, the implementation details are here. We are using TensorFlow Object Detection API and Protobuf program provided by Google. Basically, we created our own dataset of stationary images. We were focusing on non-iconic images. Um, Basically, what we did is like we adjust the resolution of our images to 800 into 600. This is the code for it, for doing that. Then what we did is like we labeled those images using label img tool, and which gives us xml files with the annotated data. Then we wrote a code to convert this xml to csv files. This is the code for doing that. Then we from the CSV files we generated TF records. Before that, we divided our data into test and train data. We generated TF records for both of them. This is the code for doing that. Uh, then we created a label map file, which essentially tells during the training that what are the classes that we are that we are going to use. I'll show you the file. This is the label map file. We are using three classes. One is calculator, pencil, and eraser, and these are the IDs for those classes. We have implemented using faster RCNN. Let me show you the faster RCNN inception v2 files. These are the faster RCNN inception v2 files, and I will show you the configuration of it. This is the configuration file for it, and we need to specify the number of classes, and we need to give our uh, a few configuration details like train records, label maps, model name, again test record file path, etc. uh, then uh, then we can start train our model using our training data. Our model versus model in the reference papers. Basically, we followed the same approach in the reference paper, but our implementation is different. As we told, we are using faster RCN for better accuracy and faster results. And when it comes to enhancements, this I already told you, as we created our own data set, and uh, while training, we use an iterative approach where we use TensorFlow to track our loss on data during training, and we adjusted a smoothing factor to get accurate results and better bounding boxes. Let me show you the code for training, and uh, uh, this is the code for training. And after training, it gives it generates models, and we need to extract the inference graph out of those models. The code for doing that is right here. uh, Once we train the model and we generate inference graph, we can test our model on our testing data. That is our test data. I will show you that. uh, this is code for testing. This is stationaries Jupyter notebook. This is the code for testing the data. Here we are giving the inference graph that we extracted from our model, which were trained on our training data. These are the results that we got. Uh, the next step there are some sample outputs here. The next step we are trying to do is like we create a webcam based application where webcam opens and we show any object, or in front of it can detect it. We are trying to do it using OpenCV. Later we try to evaluate our models by comparing them with other available CNN models, I mean algorithms and approaches, then extend our implementation or our model to train on Coco dataset and test it. Maybe if time permits, we can fix few hyperparameters and draw inferences and compare them. This is what our future course of action will be, and this is what we want to do before we submit our final completed project. These are our references. That's it. Thank you.